Data types are a key aspect in all programming languages. They tell us what kind of information something is. Data types explain if it is a number, word, true-false value, or something else. They determine what we can do with the data, how it is stored, and the range of values it can have. Understanding data types is necessary for writing good code. They make sure that variables have the right values and help the computer use memory effectively. Python supports different types of data. These data types are divided into two main categories: primitive and collection. Primitive data types. These are the essential building blocks for storing simple values. They represent single pieces of data and are directly manipulated by the computer's memory. Primitive types in Python include numeric types. Python has 3 numeric types. Integer. These are whole numbers, positive or negative, without decimals, of unlimited length, like 5, -7, 0. Float. This is a number, positive or negative, containing 1 or more decimals. For example, 1.23 minus 4.5, 7.0. Complex. The complex type represents numbers with a real and imaginary part, such as 3 plus 5j, where j denotes the imaginary unit. These complex numbers support arithmetic operations and have methods to access their real and imaginary parts separately. Boolean. This type is used to represent truth values, true and false. It's often used in conditional statements and loops. String. This is used to represent text. Strings in Python can be created using single quotes or double quotes or even triple quotes. Binary types. The data types bytes and byte array represent sequences of bytes. They are particularly useful for working with binary data or interacting with low-level system operations that require direct memory manipulation. None type. None is a special constant in Python that represents the absence of a value. It's a built-in constant of the none-type data type. We often use none to indicate that a variable or function doesn't have a meaningful value or doesn't return anything. Collection data types. These are more complex data structures used to organize and store collections of items. They are built on top of basic types and provide a way to group related data together. Here are some common collection types. Sequence types. These are ordered collections of similar or different data types. Python has 3 sequence types. List. A list is a collection which is ordered and changeable. It allows duplicate members. For example, fruits, equals, and some fruit names in brackets. Tuple. A tuple is a collection which is ordered and unchangeable. It allows duplicate members. As a case in point, profile, equals, and several items in parentheses. Range. While range itself isn't a traditional data type, it's a special built-in function that generates an immutable sequence of numbers. This makes it commonly used for looping a specific number of times in for loops. One instance is range 2 and 7 as arguments in parentheses. Mapping type. Python has one mapping type called dictionary. A dictionary is a collection which is unordered, changeable, and indexed. In Python, dictionaries are written with curly braces, and they have keys and values. For instance, car equals several keys values inside curly braces. Set types. These are unordered collections of unique elements. Python has 2 set types. Set. A set is a collection which is unordered and unindexed. It does not allow duplicate members. Let's say, clothing equals names of several types of clothes in curly braces. Frozen set. The frozen set is the same as set except its elements are immutable. This means that elements of a set can be modified at any time, but elements of the frozen set remain the same after creation. This is similar to the set example, but it uses the built-in frozen set function to create an immutable set. Each of these types has its own characteristics and uses, and understanding them is key to mastering Python. We will discuss each of them in more detail in upcoming sections. But before we delve into the specifics of data types, let's go over a few important topics. Dynamically typed. In Python, variables are dynamically typed, which means that you don't have to declare the type of a variable when you create one. Unlike languages like C and Java, where you have to declare the type of a variable and stick to it throughout the program. Let's look at an example in Java. In this example, x is a variable that stores integer values in Java. If we try to assign a non-integer value to x, an error will occur. Here is the same example in Python. First, we give x a number value, but then, on the next line, we change x to have a text value instead of a number. Python allows this and runs the code without any issues. However, Python automatically determines the type of the variable based on the value assigned to it. Additionally, Python allows variables to be reassigned to different types of values during runtime. This flexibility of letting data types change makes Python easier to use. Dynamic typing has both pros and cons. Let's take a quick look at each side. On the plus side, ease of use. Dynamic typing in Python makes the language easy to use and quick to write. We don't have to specify the type of a variable when we declare it. Flexibility. We can change the type of a variable on the fly. This flexibility can be particularly useful in certain scenarios. Less boilerplate code. Since we don't have to declare variable types, the code is less cluttered and easier to read. On the downside, runtime errors. Since Python is dynamically typed, type errors are only caught at runtime. This means if you try to use a variable as a different data type than it actually is, the program may fail while running. Debugging difficulty. Debugging can be more challenging because errors related to incorrect variable types are not caught until the program is run. Performance. Dynamic typing can lead to slower execution speed because determining the type of a variable is done at runtime. Understanding the pros and cons of dynamic typing in Python can help you write code that is more reliable and performs better. It's important to use dynamic typing thoughtfully and be aware of potential pitfalls. Type annotations, also known as type hints, are a feature introduced in Python 3.5. They allow you to optionally label the data types of variables, function parameters, and return values in your Python code. This helps explain what kinds of values a piece of code is expecting or producing. While Python doesn't require type annotations, adding them can make your code easier for other programmers and yourself to understand in the future. The annotations act like documentation embedded right in the code. Type annotations are written using the colon syntax after the variable or parameter name. For example, age, int, equals 25. Name, str, equals John. Type annotations are optional and don't change how your code runs. They just help explain the types of data being used throughout your program. Modern code editors can also use the annotations to provide better auto-completion, error checking, and other helpful features.